not much is being said about the pronounced Oumuamua these days. You remember the first interstellar visitor to our solar system? While acknowledging scientific hypotheses and speculations around this object, I'm making my own discoveries. My current analysis on Oumuamua is nothing short of something very few have seen. So, if this interests you, then stick around, because what I am about to tell you could change everything you know about the first interstellar visitor. As an exercise in the craft of forensic image analysis that I've been doing ever since 3i Atlas made its debut on the 1st of July to provide consistency across multiple image analysis, I've decided to extend this to the first interstellar object, Oumuamua, and the second one, 2I Borisov. You'll notice that I am using one specific image of the object here. Now, this image was taken by a leading scientist called David Jewett. He had access to the Hubble telescope at the time, and he took the various layered shots and calibrated the image and came up with this over here. You can see his shot, which I have converted into black and white. You can see it up in the corner there on the right-hand side in this image over here. But I just want to specify right now that this analysis that you are seeing here is not affiliated with NASA nor David Jewett in any way. When I first encountered this image of Oumuamua, it was a year ago on YouTube, I remember, one of those podcasts that was doing the rounds. And I've come to understand that most of the data available about the artist are, in fact, artist impressions. Very good ones, even the animations. And I believe that the first podcasts that I saw a year ago were not based on real data, and that the astronomy enthusiasts that were presenting these podcasts might not have actually been knowledgeable that a lot of that imagery was just very good artistic impressions. I recently saw a podcast by the Gemini big telescope, and the scientists confirmed that when they found Oumuamua, they only had 1 week in which to capture all the sides. And that means that they only didn't have enough time to create a 3D impression of the object. And that is why we are still left to this day with the speculation that what we are looking at is either cigar-shaped or a disc. Now, when I analyze this image that I extracted from the David Jewett NASA image, I'm going to tell you that what I think I see is a cigar shape. However, if I go into that image, the reason why I say cigar-shaped is because I observed a typography that signals an elongated object that culminates in a point which is in the center of the object and which appears to be closer to the observer. And based on my experience analyzing 3i Atlas data, I'm going to say that what I see here in this image, is the layering of the exposures of when the object was recorded. And so what we're going to first see is the point that was closest to the telescope, and then the last layers are the ones furthest away that took the longest time to capture, and they are much darker as well because they are further away. Then if you look at the layering effect, you can get an idea of, each layer acts like a contour line. And because of its position and its configuration, you can get a more or less idea, and the amount of layers that there are, you get a more or less idea of steep slopes and gentle slopes. And if you look at the object in that way, then the cigar shape makes more sense, because it means that the object is longer than what it is wide. Now, even closer observation. I'm going to refer to this as the nose cone, like a space rocket would have. If we're talking about a long cigar shape with a nose cone, then we are looking at something similar to what a space rocket would look like. Not so. I'm not implying that it's a space rocket, but I'm implying that we keep that in the back of our mind so that we've got a framework in which to visualize this object. The geometry of this, I believe, is relevant. Look at the geometry of this nose cone. We see an irregular octagon with two smaller sides slipped in opposite each other. A lot like when you look at a crystal shard from the top. You get these very definite sides which are long, and interspersed with that you get smaller sides which you can't necessarily fit into a bigger geometry. But if you were going to do that, then this nose cone would have 10 sides. But I'm going to stick with an octagon because later on we'll be able to do some geometric math and the outcome could be quite interesting. So the reason why I keep on referring to a crystal shard is because that's what this thing reminds me of. It's also got a way of bouncing the light that is determined by that octagon shape and the greater part of the body as it extends backward. There definitely is a shininess to it, although scientists also say that it has a reddish tint to it, which of course suggests iron oxide compounds, similar probably to what we see in 3i Atlas. Now, back to the crystal analogy. I'm also thinking about those old crystal radio sets. Remember those from the 1960s? Now, in the crystal radio set, the crystal that they used was quite specific. Here are the names of some of them. A lead sulfide crystal, an iron pyrite, and silicon carbide. Now, those are just three of them, but the point I'm trying to make here is that these are crystals that can emit a radio signal, that can receive a radio signal, an AM radio signal. Just something to keep in the back of your mind when you think about Oumuamua. Now, there is also an interesting looking tower-like needle. You see that extends off one side of the object. The location of this is at the far end of the object because it is situated in one of the last layers, well actually the fifth last layer of the calibration. And on the opposite side, at a precisely 125 degrees, is another feature even possibly more significant because of its stature and its size. Now, if you look at the shape of this image, first of all, it consists of the last 6 layers. Now, this is important when I say the last six layers of the calibration, because first of all, that structure resembles something like a fin, on a rocket, or something that contains a thruster. I'm just saying as an image, not as an possible outcome, but as an image to keep in the back of your mind when you're creating an idea of what this object might look like. This is an extension arm. Now, is it really there, or is that just part of the calibration? My analysis shows that it is possibly there. Now, the reason why I say that, because if you look at the needle on the opposite side, you'll notice that the needle sits on layer number 5, and that's the layer where this arm begins. And if you go down another couple of layers, you come to the final layer that makes up the shape of that arm. Now, if we were to take away the needle, eliminate it from the picture, all those layers, then we eliminate everything, including the swirling gas formation that swirls around the object. I think those are important, and that's why I've kept them in. If I keep the swirl of the gas plume there, then we are dealing with this arm and the needle. If you look at that needle shape, there's a distinct formation of a gas plume. That's why I'm assuming that is possibly a gas jet, almost like an exhaust pipe would act, because you can see a gas jet coming out and you can see it's going in an anti-clockwise direction. That's why I would speculate that the object is spinning in a clockwise motion. That should throw the gas plume back in the opposite direction. Let me know in the comments below what you make of this formation, and if that is how you perceive the gas would be flying, for example. It would be interesting to know what you think about that. Now back to Oumuamua and the nose cone. From this irregular octagon, we now traverse forward towards the viewer, okay, and towards the cone tip, where this octagon, it actually morphs into a trapezium. Now, in this image, I have tilted this one over here. I've tilted the image 90 degrees to the right, so that you can get an idea of the kind of impact that that trapezium has. Because when you look at the image as a whole, this analysis of Oumuamua, you don't really notice the tip unless you actually zoom into it. If you look at this drawing, this sketch over here, you can get an idea, an artist's impression idea based on this image analysis of a possible outcome of a side view of what we are actually looking at. That includes an impression of the cone tip, what I'm speaking about here. So here you can see how that cone tip levels out and then morphs into the tip itself. And when one looks at that tip, it's not easy to get an impression of that tip with the actual extraction, because there's a pixel loss that happens on the video. But what it appears to me on my software is a pentagon. If you look at the geometry of the nose cone itself specifically, we begin with either a 10-sided figure, but I am going to go with a irregular sided octagon. Then that morphs into a trapezium, which is a irregular 4-sided quadrilateral shape of which 2 sides are parallel. More than less. This one over here. You can also let me know in the comments what you think about whether this is rather a quadrilateral or a trapezium. I am of the notion it's more of a trapezium. And then that morphs into a pentagon. I find that very interesting as a number, 845. Just something to think about. So my friends, before I go any further, I'd like you to note that if you would like to be notified of more content, more forensic analysis of our interstellar visitors, then smash the notification button, subscribe, and like the video, because your like tells the algorithm that this video is worth watching. So we see that the geometry of the nose cone is 8 to 4 to 5. What do we make of that? The main body extending backward from here toward the rear of the geometry. Well, it's not much of a geometry around at the back there, but it's still more or less of a of a disc shape, not a disc itself, but a roundish square shape. And so that's it, my friends. That's all for now. Thank you for watching, and be on the lookout for my next video discussion, where I'll be breaking down 2I Borisov. Until next time, may the force be with you.